Hi Zach, this is Mr. Ty. I'm going over your test, and overall you're doing quite well, especially for the fact that you're working through this on your own. Two things to go over to make sure you're good and ready for the actual test, and that is one, dealing with trigonometry when your angle's greater than 90 degrees, and two is the ambiguous case of the sine law. So those seem to be the two main things missing, and if we take a bit of time to go over them, you should be good. So this first question here, it says, for angle A, sine A is 3 over 5. Find all possible exact values for the cosine of A and the tan of A. Now here's what that means. To deal with angles greater than 90 degrees, we redefine our trigonometric ratios. So you're used to the angle having an opposite, an adjacent, and a hypotenuse side. And that was based on the inside of a right-angled triangle. This angle cannot exceed 89.999 degrees. If it reaches 90, you no longer have a triangle. So we redefine trigonometry a bit and take our angle as being counterclockwise from the positive x-axis. So that same angle drawn into here still gives us a right-angled triangle, but this side length here is the y value. This side length here is the x value, and we call this r. It stands for radius because the idea is you have a rotating arm here. That makes sine y over r. Cosine is x over r, and tan, which was opposite over adjacent, is now y over x. Now we're going to apply this to question 1. Okay, you can pause it there, copy this out if you need it. Okay, so it says here the sine of A is 3 over 5. Now I'm just going to draw that. That's a 3, and that's a 5. This is a right-angled triangle, and you can verify this for yourself via the Pythagorean theorem. This side length here has to be 4, because 4 squared plus 3 squared is equal to 5 squared. That side there is 4. Alternatively, and that's our angle A. Alternatively, it could be over here, because our requirement is only that the sine of A is 3 over 5. So if instead we have this long angle over here, that could still be a 3, that could be a 5, and that could be a negative 4. So that gives us two possible answers. For the sine of A to be 3 over 5, A could be here, but it could be all the way across here. So the cosine of A could be 4 over 5, or it could be negative 4 over 5, and we'd still have the sine of 3 over 5. So my two answers for the cosine of A is that it could be 4 over 5, or it could be negative 4 over 5. If you go to page 6 and practice question 4, there's a lot of questions similar to this, same type of skill. There they specify which quadrant, but other than that it's the same idea. Sine of A is 3 over 5. So what's the tan of A? Well, we can look at this again. The tan is y over x, so the tan could be 3 over 4. Or it could be 3 over negative 4. And we bring the negative to the top, so we'll say it's or negative 3 over 4. Now, to find each possible angle A to two decimal places. To find the first one, you know that the sine of A is 3 over 5, so that makes A the inverse sine of 3 over 5. It's actually pronounced arcsine, but don't worry about that. So we have 3 divided by 5, and we want to take the inverse sine of that. Gives me 36.8 degrees. Oh, it would round up. Let's call that 36.9 degrees. That gives us this angle here. If we go all the way across, that's 180 degrees, and then come back by that same angle, that gives us 180 minus 36.9. So my second possible answer between 0 and 360 degrees, it's or 180 minus 36.9, which is 143.1. Okay, so here I asked to use a special triangle to find the exact value of the trig ratio and then sketch it on the coordinate axis. So everything was good, you just have to sketch it. And to sketch the angle of 210, if you go all the way from here to here, that's 180, and we have to go an additional 30 to give us an angle of 210 degrees. Okay, so same thing over here. I used a marker so this would show up well in the video, so it looks like it's run its way through, but you had everything right. Cosine of 300 is a half, and then if you were to sketch 300, it's just 360 minus 60. So that makes it about here. That's 300 degrees. And the tan of 120 is root 3, and that's of course right. So you're fine with this part. It looks right here like you used the correct cosine law, and then just had a little bit of trouble calculating it. I think given a bit more time, since you had everything set up right. Only thing that's missing is this angle has to go in here. So make sure you sub that angle in. Follow the correct order of operations and the answer should come out right. Okay, now here, you use the sine law correctly, but we're into the second sort of main point that was missing, and that is the ambiguous case of the sine law. Whenever you solve a problem using the sine law, it's possible that there are 2 correct answers instead of just 1. And this is one of those cases. So when I draw out this triangle, given the specs here, so it says here that A is 20, B is 32, and angle A is 20 degrees. So I'm going to draw that out. So I'm making this right here 20 degrees. This is 32. And my side length, which is across from the 20 degrees, is 20. Now, I'm drawing it with a dotted line because it could be here or it could be here. See how there are 2 possible triangles to satisfy this? Where that's a side length of 20 or that's a side length of 20. So our answer could be this triangle that looks like this, or it could be this triangle that looks like that, so including the outside here. When you use your calculator and the sine law, it's going to give you the acute angle here, and then we're going to use the coordinate axis to find the obtuse angle that would go there. So when you use the sine law, you end up with, and I'll let you run through it yourself, I'm just sort of going straight to the answer here, the inverse sine of the sine of 20 over 20 times 32. And that gives you 33 degrees. And you had that right. Well, you had 32. I think within rounding, you'd done the right thing. Okay, so that makes this angle here 33 degrees. So that's one possible answer for the value of B. That gives us our solution with this triangle here, where that's 32, that's 20, and that's 33. The other possibility is that we have this triangle inside here, where that's still 32, as per our specs, that's still 20 degrees, but the angle comes in this way, so that's a side length of 20, and you have an obtuse angle here. So what you're really looking for is an obtuse angle whose sine is also 33 degrees. And here's how we're going to get that. Right here we have a sine, here we have an angle 33 degrees. And if I draw a line this way, where that's also 33 degrees, this angle is going to have the same sine as this angle, because they both have the same y value and the same r value. And sine is y over r. So that makes this angle here 180 minus 33, or 147. So your two valid answers, ask for all possible values. You have 32 instead of 33. I'm just going to assume it was a rounding error because you have the sine law set up correctly. So your other possible answer is 180 minus 33, which is 147. So I ask for all possible values. That's the other one. This doesn't happen whenever you use the sine law. It only happens in a particular case. When you set things up for the sine law with your given information, say you're given an angle here, you're given a side length here, and you're given this side length here. See how there are two ways for this triangle to form? There are two ways for that triangle to form. If side length A is longer than this line here, this altitude, this right angle line here, and the length of that line, the length of that guy is going to be B times the sine of A. So if A is greater than B sine A, you have two possibilities here. It could work like this or like this. If A is equal to B sine A, then there's only one triangle that can be formed. And if A is less than B sine A, there's no triangle that can be formed because it doesn't reach. There's also an alternate possibility, and that is that A is greater than B, and that would change things as well. If A was greater than B, then the triangle would not work on this side, and it would have to go back out that way. So you'd only have one possible triangle. I hope this helps, and send me a message. Let me know when you're ready to write the actual test. If you need further explanation, just feel free to send me a message as well and let me know.